Today we are going to talk about a life-saving piece of equipment found in hospitals and even some public places. And I bet you know what this is. Pause the video here if you want to make a guess. In this video we'll cover the engineering behind how a defibrillator works, what it does, and some of the challenges in designing them. Let's get into it. A defibrillator is basically an energy conversion and control system that delivers a controlled high-energy electric shock to the heart through the chest wall. This is done to restore normal rhythm in the case of ventricular fibrillation, VF, or pulseless ventricular tachycardia, VT. In these conditions, the heart's pumping action is ineffective because the ventricles are quivering instead of contracting in a coordinated way. The defibrillator doesn't restart a stopped heart, but it does depolarize a critical mass of myocardium, allowing the sinoatrial node to reestablish normal rhythm. To do this, it has three main components. First, a power supply and charging circuit that converts the 120 or 230 volts. AC mains or battery in the case of a portable AEDA lithium-ion battery to the high voltage needed to deliver the shock, typically between 300 and 2000 volts. This is done using a step-up circuit that uses a DC-DC converter to raise the voltage and then charges a high-voltage capacitor to a preset value. A microcontroller monitors the charge level, and when it's ready, it sends a signal to the discharge circuit. The energy is stored in the capacitor, which is basically like a big battery that can hold a large amount of electrical energy. The amount of energy stored is calculated using the formula E equals 1/2 CV, where E is the energy in joules, C is the capacitance in farads, and V is the voltage in volts. For example, a 200 microfarad capacitor charged to 2000 volts stores approximately 400 joules of energy, which is typical for many defibrillators. The energy is released or discharged from the capacitor through a controlled switch made of thyristors or IGBTs. The energy flows from the defibrillator through the wires and electrodes or paddles placed on the chest and into the heart. A pulse-shaping circuit ensures that the waveform is both safe for the patient and effective at defibrillating. Older defibrillators used a monophasic waveform, which delivers a one-directional current, while modern defibrillators typically use a biphasic waveform, which reverses the direction of current during the pulse. Biphasic waveforms require less energy to defibrillate the heart and are safer for the myocardium. But they also need a more complex waveform shaping circuit. Once the waveform is created, it's delivered through the electrodes, which can be in the form of paddles for manual defibrillators or adhesive pads for automated external defibrillators or AEDs. To reduce contact impedance, the pads may be covered in gel or saline solution. Some defibrillators measure the impedance between the pads before delivering the shock, so they can adjust the voltage to ensure the proper amount of current flows through the patient's chest. The entire process of charging, delivering, and shaping the shock is controlled by a microcontroller or FPGA, which also handles any necessary synchronization with the ECG, as well as safety interlocks to ensure that the shock is only delivered when needed. The control system also records events such as time, energy, and patient ECG for later review. For manual defibrillators, the control system may include buttons, an LCD, and voice prompts to guide the user. In contrast, fully automated external defibrillators have no user interface, since they automatically analyze the ECG and deliver shocks when necessary. They often have a shock button that requires the user to press down firmly to avoid accidental shocks. Both types of defibrillators will warn the user before discharging. In addition to these external defibrillators, there are implantable cardioverter defibrillators, or ICDs, that are surgically implanted inside the patient's chest. These devices monitor the heart's electrical activity continuously and deliver shocks or pacing therapy as needed. So that's a quick overview of the defibrillator. You enjoyed this video? Please hit the thumbs up button below. Thanks for watching, and stay tuned for the next video.